Good morning, everyone. Here we start a new unit, thermodynamics. Let's see some of the basic concepts in thermodynamics. First of all, we know thermodynamics is the branch of science that deals with the energy levels and the transfer of energy between systems and different states of matter. So, when we study the term thermodynamics, the first thing we notice is a system and a surrounding. We know there will be a system, any thermodynamic system which is under consideration, and there will be a surroundings, and these two are separated by a real or imaginary boundary. So, let's see what is a system. A system is a quantity of matter or a region in space chosen for study. So it can be anything under the universe which is under investigation. So other than the system, everything is called the surroundings. We can say the mass or region outside the system is called surroundings. Now, a boundary means a real or imaginary surface that separates the system from its surroundings. So these are the main things we come across in thermodynamics. We have a system. We are considering the part of the universe which is under consideration is called the system, and the rest of the universe is called surroundings, and this system and surroundings are separated by means of a real or imaginary boundary. Now let's see the different types of systems. First of all, we have three types of system mainly. They are called open system, closed system, and isolated system. To explain this concept, let's take the example of a cup of tea. An open cup of tea, a closed cup of tea, and tea taken in a thermoflask. So let's begin with an isolated system. If you consider a tea taken in a thermoflask, we know there is no energy exchange and matter exchange. That means even after a long time, that heat will be maintained, the temperature will be maintained, and the substance, the amount of substance also will be unaltered after a particular time. That means in an isolated system, such a system is called an isolated system, and in that there is neither the exchange of matter nor energy with the surroundings. So, such a system is called an isolated system. Example, coffee or tea in a closed, well insulated thermoflask. And the next type is closed system. We can consider a closed cup of tea. A closed cup of tea means if we keep it for a longer time, it will become cold. That heat will be passed out to the surroundings. But the amount of substance, the matter won't be reduced in quantity. So that means that system, a closed system, can exchange only energy with the surroundings, no exchange of matter. Example, a tightly capped cup of tea. Now we have the third type of system, which is open system. In an open system, say for example, if you keep a cup of tea open for a longer period of time, after some time you can see that tea becomes cold, as well as there will be a slight reduction in the volume of the tea. That means there is exchange of energy as well as matter with the surroundings. So such a system is called an open system. An example for such a system is an open cup of tea. So generally we can say an isolated system can exchange neither heat, neither matter nor energy with the surroundings, while a closed system can exchange only energy, not matter with the surroundings. And finally, an open system can exchange both energy and matter with the surroundings. So these are the different types of systems. Now let's see about different macroscopic properties. So in thermodynamics we come across with so many types of properties, different macroscopic properties, and generally we can say any characteristic of a system in equilibrium is called a property. So there are different types of properties, and these macroscopic properties are mainly classified into two types. They are called extensive properties and intensive property. So first of all, let's see what's an extensive property. Extensive property means these are the properties which vary directly with the size of the system, or we can say these properties depend on the quantity of matter. So it is these extensive properties are dependent on the amount of substance present. For example, when you say volume or mass or total energy, or let's say internal energy, enthalpy, all these terms are mass dependent. When the mass of the system varies, these properties also varies. So such properties which are dependent on the amount of substance is called extensive property. Many of the thermodynamic properties like internal energy, enthalpy, free energy, volume, all these are dependent on the amount of substance. Now, another type of property which are independent of the size of the system. The properties which are independent of the amount of the system are called intensive properties. Example, temperature, pressure, refractive index, boiling point. We know these are some common properties. When you say boiling point of water is 100 degree, that means whether you take 100 ml of water or 1 liter of water or 5 liter of water, whatever be the quantity of substance you are taking, its boiling point is constant and it is 100 degree. The same way, refractive index. So these are constant property. They are not varying with the mass of the system. So such properties which are independent of the amount of the system are called intensive properties. Now we have some other properties. That means if you take the ratio of an extensive property, the ratio of two extensive properties will be intensive. For example, density. Density is the ratio of mass to volume. So that is the ratio of two extensive property, and such properties will be intensive. And also when we say extensive property per unit mass, they are also intensive because there the mass is fixed. We say the mass is fixed. For example, specific volume, that is volume by mass, or density. Then we say molar enthalpy. Molar enthalpy means enthalpy of 1 mole of the substance. There also it will be a constant because for 1 mole of the substance there will be a particular value for molar enthalpy, or molar entropy, molar free energy, specific heat capacity. So these are all the terms where the amount of substance is fixed, or it is per unit amount of the substance we say. So for such properties, they are independent of the amount of substance, and we can say they are intensive property. So the ratio of two extensive properties or extensive property per unit mass etc. are intensive properties. Now let's see the different types of thermodynamic processes. First of all, isothermal process. Isothermal means the name itself indicates the process that takes place at constant temperature is called an isothermal process. So every process which takes place at constant temperature, that means delta T value will be 0. So in order for delta T to be 0, we know that there must be heat transfer between the system and surrounding. Only then the temperature can be maintained constant, because during a process, for example, there can be some heat produced or some heat can be absorbed. So as a result of this, the temperature should change. So in order to keep the temperature constant, there must be heat transfer between the system and surroundings. So that's why we can say the condition is delta T is equal to 0 and delta Q. Delta Q means heat transfer, that is not equal to 0. So which is the condition for an isothermal process. Now another type of thermodynamic process is isobaric process. So isobaric process means a process that takes place at constant pressure. So here delta P is equal to 0. That means pressure change should not be there for an isobaric process. In the same way we have isochoric process. That means a process which takes place at constant volume. Constant volume means delta V should be 0. Then we have adiabatic process. Adiabatic process means a process where no heat transfer between system and surroundings. Such a process is called an adiabatic process. If you consider a process taking place at an insulated condition, at perfectly insulated condition, then we know there will not be any heat transfer between system and surroundings. So delta Q will be 0 for an adiabatic process. So since there is no heat transfer, definitely the temperature of the system should change. Temperature should either increase or decrease. Okay, so we can say the conditions for an adiabatic process is exactly the reverse of an isothermal process. That is, delta T should not be 0 and delta Q is equal to 0 for an adiabatic process. Next type of process is a cyclic process. A cyclic process means this is a process in which the system can return to its initial state through a series of steps. So whatever be the number of steps taken, if the system through a series of steps, if it returns back to its initial state, exactly back to its initial state, it is called a cyclic process. Then we have a reversible process. Reversible process and cyclic process are different. A reversible process means a process in which the system and surrounding can be reversed exactly by small change in any of the variable. That means by slightly changing any of the variables, if the system and surrounding can be returned to its, or it can be exactly reversed. Such a process is called a reversible process. For example, we know the freezing point of water is 0 degrees Celsius. So if you have a system in equilibrium, that means you have solid ice and liquid water is in equilibrium at 0 degrees Celsius. So if you reduce the temperature, you can make the whole thing solid. But if you slightly increase the temperature, it will be converted to liquid state. So that means here by small variation of the parameter temperature, by varying the temperature, you can exactly revert the process. So that is called a reversible process. Here in the case of freezing of water, we are changing the variable temperature. By slight variation in temperature, we can revert that process. Freezing of water, that will be, ice will be converted to liquid state and the liquid will be converted back to solid state by varying the temperature. And if we cannot do such a process, like if we cannot do such a reversal, that means a process where the system and surrounding can't be reversed exactly back, that is called an irreversible process. For example, burning of coal. If you are burning coal, carbon will be burned, and once it is burned, you cannot revert it back to the coal stage. So once done, the reaction is done. There is no possibility of reversal by varying the variables. So such a process is called an irreversible process. So these are the different types of thermodynamic processes. We have isothermal process, isobaric process, isochoric process, adiabatic process, cyclic process, reversible process, and irreversible process. Another important term in thermodynamics is thermodynamic equilibrium. So if a system is said to be, we can say a system is said to be in thermodynamic equilibrium when it does not undergo any spontaneous change of its macroscopic properties such as pressure, volume, temperature, etc., and it is in complete balance with its surroundings. So such a system, such a state is called a thermodynamic equilibrium. So if a system is said to be in equilibrium, there won't be any change of its, there won't be much spontaneous changes. Spontaneous changes won't be there in any of the macroscopic properties, and there will be a perfect equilibrium, perfect balance between the system and surroundings. For example, when you have a reaction, a chemical reaction, for example, in the formation of ammonia from nitrogen and hydrogen. So initially, when you start the reaction, initially the rate of forward reaction will be very high, and with the passage of time, there will be some backward reaction. The formed ammonia gets reverted back to the reactant stage. And if we do not change any of the conditions, if the conditions are unaltered, we'll get a particular stage or an equilibrium stage where the rate of forward reaction will be equal to the rate of backward reaction. So there will be a complete balance between the forward and backward reaction. So such a state is called a thermodynamic equilibrium. Now, another important term in thermodynamics is heat. We can say heat is the form of energy which transfer without the transfer of mass from one body to another body from higher temperature to lower temperature by virtue of temperature difference between the two bodies. So whenever you have temperature difference between two bodies, there will be transfer of energy from the higher temperature one to the lower temperature one until the temperature of both becomes equal. So this the form of energy which transferred, that is called heat. For example, we know if you have a cold water in a vessel and if it is kept in a beaker containing hot water, so then there will be transfer of heat, transfer of energy between the two until the temperature of both becomes same. So that form of energy transfer, that is called heat. And this heat transfer occurs by virtue of temperature difference. Whenever there is temperature difference, then only this heat transfer occurs. And let's see the sign convention for heat. If heat is absorbed from the surroundings, such a process is called endothermic process, and that Q, heat is represented by the letter Q, and Q will be given a positive charge for an endothermic process where heat will be absorbed from the surrounding. And if in other case, if heat is liberated to the surroundings as a result of any process where if heat is liberated to the surroundings, such a process is called an exothermic process, and in that case Q is given a negative sign. So this is the sign convention for Q. For endothermic process Q is positive, and for exothermic process Q is negative. Now, just like heat, we have another term in thermodynamics that is called work. Work is another kind of energy which is different from heat. This is also an energy transfer, but work can flow in and out of a system. There is no restriction or there is no condition that there must be a temperature difference. We have the equation for work done. The work is denoted by the letter W, and it is the product of force and displacement. In order to displace a substance, if F is the force done to displace by ds, so then we can say the work done is equal to force into displacement. Okay, so the heat can transfer only when there is difference of temperature between system and surrounding, whereas work transfer can take place even without the change in temperature. So a temperature difference need not be there for work transfer. That is the difference between work and heat. And the similarity between work and heat is that both are called path functions. In thermodynamics, we have two types of functions, a state function and a path function. State function means These are the functions which depends only on the initial and final state and not depending on the path by which the state has attained. For example, most of the thermodynamic properties are state functions. Enthalpy, entropy, all are state function. And heat and work are path function because they depend on the path by which the state is reached. So, path is dependent for heat and work. So, these two are path function while other thermodynamic properties are state functions. So, with these initial concepts, introductory concepts, let's wind up today's lecture. So, in the next videos, we can discuss more about the first law of thermodynamics, entropy, second law, etc. So, thank you.